Genetics Practice 1, Basic Mendelian Genetics. And this is a worksheet from AP Biology, and it's ridiculously easy, so you guys will have no problem with it. So you're going to solve these genetic problems and be sure to complete the Punnett square to show you how you derived your solution. And so in humans, the allele for albinism is recessive to the allele for normal skin pigmentation. If two heterozygotes have children, what's the chance that a child will have normal skin pigment? What's the chance that a child will be albino? So in this one, they don't give you the letters that you're supposed to use, so you get to pick whatever letter of the alphabet that you choose. Tradition is to go with the dominant trait, and so the albino is recessive, which means normal skin must be the dominant. So I'm going to use the letter N. To help me out a little bit, I'm going to do a little key on the side. So I'm going to put big N would be normal, big little would be also normal, my heterozygous there, and then my homozygous recessive little n would be albino, just so I know which alleles I'm working with there. So if two heterozygotes have children, that means that the parents of these guys are big N, little n. What are the chances we'd have normal skin and the chance it'll be albino? So down here, when I'm writing this out, since it's heterozygotes, I know that this parent can inherit or donate the big N and the little n, as can this parent over here. So when we complete our Punnett, it's pretty simple. You should be getting to the point where you can almost do these in your sleep, and you would come up with that. So we want to know, the question's asking us is, what is the chance that we're going to have that? Now, they don't talk in terms of the frequency or the percentage or the genotypes. So for right now, I'm going to go with the percent chance. And so with a normal pigment, what are the odds our kids are going to be normal? Well, if we look here, we'd have normal, normal, normal. And so that means we have a 75% chance of normal. And just so I know the teacher knows what I'm talking about, I'm going to put big N, and big N, little n in parentheses here. What are the chances that it's going to be albino? Well, 1 out of 4. So that would be 25% would be albino. And just so we know, that is the little n, little n. So if the child is normal, what is the chance that it is a carrier, heterozygous, for the albino allele? And be careful. So this is a trick question because they're asking us to just look at the normal kids. So I would cover this one up, and I have out of my 75% chance right here, so just looking at these three squares, what is the chance that our baby's going to be heterozygous? And so 2 out of 3. So you could put here 2 out of 3, or that could be 2 to 1, or that could be about 67% chance that it is a carrier. So we have to ignore our percentage of albinos, just look at our percentages of normal kids and factor that one that way. That's why you have to be careful. But I gave it to you. Merry Christmas. As you go down through here, they're pretty easy little questions. This one, looking at the purple people eaters, 1 horn dominant, no horns recessive. I would do like we did up here and put a little key on the side so you can remember. And then it asks you to summarize the genotypes and phenotypes of the possible offspring. And so I will give you the option. You can do it as a percentage, you can do it as a ratio, or you can do it as a fraction. Any of those are acceptable since this particular worksheet doesn't specify how to present your answers. So you're going to give the genotype information and then the phenotype information. You're going to do that for this worksheet, and you're also going to do it for its buddy over here. And I have the key at the front, so when you get stuck, please come on up and ask. Thank you.